Hey guys, Dr. Cadell here, and this is acid-base titrations. The basic idea with this experiment is you're going to first prepare a stock solution of sodium hydroxide. To do that, you're just going to add about 25 milliliters of 6 molar sodium hydroxide to an Erlenmeyer flask. Add, some deionized water, and I'll show you that in a few minutes. That'll be your stock solution. We don't prepare that carefully at all because we're going to figure out the concentration of sodium hydroxide in that stock solution as part of the experiment. Once you have your stock solution, you're going to standardize it, which is where you figure out the concentration of sodium hydroxide. Then you're going to use that same sodium hydroxide solution to titrate. That means to react with some unknowns. The unknowns are acids. One's going to be a solution of acetic acid. What's unknown about that solution is the concentration, the molarity of acetic acid in there, which you'll be able to figure out from the experiment. And the other unknown is a solid unknown. And what you're going to do is you're going to figure out the molar mass of the solid unknown, which is also an acid, by the way. The basic reaction that is involved in this experiment is what's written up here at the top. Every acid in this experiment is what we call a monoprotic acid. What that means is that there's one acidic proton. In other words, there's one hydrogen in that molecule that reacts with a base, hydroxide. So we use this general symbol HA. A is for acid, right? This symbolizes any monoprotic acid. So the basic reaction is some acid reacting with hydroxide. And what hydroxide does is it pulls this proton off of the acid, leaving behind the conjugate base, the A-, and making water. For the standardization of your stock sodium hydroxide solution, what you're going to do is you're going to use an acid, a monoprotic acid called KHP. That stands for potassium hydrogen phthalate. It doesn't really matter. The only thing that really matters for you guys is, one, it's a monoprotic acid. It's a solid, so you can weigh it. And the molar mass, which I'll show you in just a moment, because you'll need that for the calculations. And I'll give that to you. So after you make your stock solution, you're going to react it with this KHP, this solid acid that you weighed out. And I'll show you the details of that when we get over there and do the actual experiment. The reaction is this same reaction here. This is the same reaction for all parts of this experiment, really. And your goal in the first part of this experiment, the standardization of the sodium hydroxide, is to find the molarity, the concentration of the sodium hydroxide. So to remind you what molarity means, concentration means, it means moles of the solute over liters of the solution. So what that means for you guys is that you need to find two numbers to find the concentration of sodium hydroxide in your stock solution. How many moles of sodium hydroxide you have, and how many liters of solution. Well, the moles of sodium hydroxide, we're going to get that because in this reaction here, in all of the reactions in this experiment, it's a 1-to-1 mole ratio between hydroxide and whatever acid you happen to be titrating, in this case, KHP. Which means that if you know how many moles of KHP you have in your flask, at the point where you've added exactly enough hydroxide, sodium hydroxide, to use up all of that acid, you'll have added the same number of moles of sodium hydroxide as you have acid in that flask. That's nice because we're going to weigh out the KHP, so we know how many grams we have, and we'll know the molar mass. That means we know how many grams per mole. So it's really easy to calculate how many moles of KHP. So if we can determine when we've added just enough of our sodium hydroxide solution to react with that KHP and no more, then we will know how many moles of sodium hydroxide we've added. This number right here. The liters of solution, that's pretty easy. We're going to use a burette, which I'll demonstrate for you in a few minutes. We can measure how much sodium hydroxide solution we've added. So that'll give us liters of solution. We have everything we need for this calculation. So if we look over here, to find the liters of solution, we're going to measure the volume of the sodium hydroxide with a burette, which I'll show you in just a minute. But with a burette, what you do is you take two measurements, the initial volume and the final volume. And so you read the burette before you add the sodium hydroxide to the acid. And at the end, when you've just used up all the acid, you record the volume again. The difference between those two volumes is the volume that you've actually added. And we read our burette in milliliters because we want our volume in liters. To find the liters of solution, we do it just like this. Take our final volume minus our initial volume, divide by 1,000 milliliters per liter. That'll tell us how many liters we've added. That's the liters of solution. So I talked about how the moles of sodium hydroxide is equal to the moles of KHP down there in that flask, right at the point where we have added just enough sodium hydroxide to use up all the KHP. The name for that point is the end point or the equivalence point. When we're at the end point or the equivalence point, the moles of sodium hydroxide is equal to the moles of KHP. Now, we'll know how many moles of KHP we have in that flask because if we look over here, we're going to weigh the mass of KHP. We'll have the grams of KHP. The molar mass, you should write this down. You guys will need this number. 204.22 grams per mole. That's the molar mass of KHP. So if we just take the grams, divide by the molar mass, that tells us how many moles of KHP we have in that flask, which means we know how many moles of sodium hydroxide. We know the two things we need. Moles of sodium hydroxide, liters of solution. Calculating the concentration is easy. A couple of things. It's really important that we know when we've added just enough sodium hydroxide to use up all of that acid, whatever it is, KHP, the acetic acid, or your solid unknown. To do that, we use an indicator. It's called an indicator. And what an indicator does for you is it changes color when the solution goes from being acidic to basic. And that's what the end point is, the equivalence point is. It's when you've added enough sodium hydroxide so that you've just used up all that acid. Right at that point, okay, it's acidic. The solution is acidic before you start adding sodium hydroxide because there's an acid in there. As you add the sodium hydroxide, it uses up some of that acid, but not all, so there's still some acid sitting down in there. It's still acidic. When you get to the point where you have used up all of the acid with the sodium hydroxide and have not added any extra sodium hydroxide, now it's a neutral solution. It's neither acidic nor basic. Right at that point, that's when your indicator will change color for you. So if you catch it right at the point where the color changes, stop there. That's where you read your final volume. That's your end point or equivalence point. So it's also important for us to read our burettes carefully. So I'm going to show you that again here. So if we look right here, burettes, a couple of things to keep in mind when you're reading a burette. First is that the top mark is 0, and the bottom mark, it's down here. In this case, it's going to be 50 milliliters. The next thing is that the smallest marks, the marks that are closest to each other on the burette, they're 0.1 milliliters apart, 1/10 of a milliliter apart. So what that means for you guys is when you read a burette, you always record that volume to 2 places past the decimal, to the 100th of a milliliter. And the next thing is when we read these, of course, because this is a liquid in a column, there's going to be a meniscus. We read the bottom of that meniscus. And so if we were to read this, if this were a meniscus in this burette, okay, first of all, the bottom of that meniscus is somewhere between 1 and 2 milliliters. So we know right off that it's going to be 1 point something. And remember, we have to go 2 past the decimal. So if we count down, it's 1.1, 1.2. It's somewhere between 1.2 and 1.3. All right, so 1.2 something. This is the part where you estimate. I said, that looks to me like about 1.27 milliliters. But if you said 1.28 or 1.26, I wouldn't argue with you. It's understood that that last digit is estimated. Still a significant figure, but it's estimated. Once we've done that, okay, what we're going to do is that titration 3 times with the sodium hydroxide. We're going to take the atoms in the end. Once we finish standardizing the sodium hydroxide solution with KHP, then we're going to do the same basic reaction, except we're going to replace the KHP with the unknown solution of acetic acid. What we do there is we use a volumetric pipette to measure out 10.00 milliliters of the acetic acid solution into the flask, add some indicator, titrate it with the sodium hydroxide in the burette. Do that 3 times, and then for the last part, for the solid unknown, we're going to weigh out some of the solid unknown into each of the flasks so we'll know the mass. Add some water, add the indicator, titrate it again with the sodium hydroxide from the burette. do that 3 times. So there's a total of 9 titrations in this lab. But that's really all there is to it. So why don't we go over here and get started doing this experiment. All right, guys, so we're going to start by making our stock solution of sodium hydroxide. To do that, we're going to use some roughly 6 molar sodium hydroxide. And I measured out about 25 mils. This doesn't have to be exact, just roughly 25 mils. I have a 500 milliliter Erlenmeyer flask. Just put the sodium hydroxide in there. And in the procedure, I say add 475 mils of DI water. You don't have to measure it. Here's all you do. See how this flask has this neck right here? If I just add water until I get up to about that neck, that'll be plenty good. Just to make sure everything's all mixed up, when it's about half full, I give it a swirl. Good to go. And now we have our stock solution, sodium hydroxide. Now we want to standardize this. To do that, we're going to weigh out KHP, potassium hydrogen phthalate. It's right here. We're going to weigh somewhere between 1 and 1.2 grams. To do that, take an empty weigh boat, place it on the balance. Tear the balance, so it says 0, with the weigh boat on there. Take the weigh boat out because we never add anything directly on the balance. There you go, 1.089. So everybody's going to have a different mass there. As long as it's somewhere between 1 and 1.2 grams, we're good. So we'll have 3 Erlenmeyer flasks. We'll have labeled them ahead of time, 1, 2, and 3. I have number 1 right here. Add the KHP to that. Because we weighed that out, we want to make sure we get all that KHP into that flask. So we're going to rinse it with a little bit of deionized water. Make sure we get every little bit of that in there. And then we're going to add about 50 mils of DI. This is not worth measuring because that volume doesn't really matter. So I'm just going to eyeball it. And say that's about 50 mils. Give it a little swirl, let it start dissolving. The next thing we have to add to our solution here, to our KHP and water, really important, is our indicator. So we're going to use an indicator called bromothiamyl blue. That's what it looks like. It's red now. When it's in an acidic solution, it will be yellow. And when we reach our end point or equivalence point, it's going to go from yellow to green to blue. So our goal, we're going to add sodium hydroxide from this, which I'll show you guys in a minute. Our goal is to make just 1 drop of that sodium hydroxide solution, make this change color. Now the colors look like this. And what we're looking for is the color to go, it's going to start out yellow, somewhere over here. Ideally, we want to stop when it gets about like this, green or so. Sometimes you can't help it. 1 drop goes right from yellow to blue. That's okay. As long as 1 drop did that, you're still good. That's what we're looking for. So I'm going to add a few drops. Doesn't really matter how much, 3 or 4 drops of my bromothiamyl blue to the solution. A little more than 3 or 4, it doesn't matter. It's starting to dissolve. I'm going to add my magnetic stir bar. Place this on the magnetic stir plate. And let it start stirring as I prepare my burette. So this is where the sodium hydroxide stock solution goes. I have a glass funnel on the top to make it a little bit easier to add. So what I'm going to do is I'm going to take this off. This is a stopcock. This is closed when it's perpendicular to the burette, open when it's parallel. So we want to start out with it closed. This, by the way, this burette has already been cleaned, been rinsed with DI water and some sodium hydroxide. So it's a little bit easier. Make sure that's closed if you bring it down like this instead of trying to pour it up there, because that's sometimes a disaster. When you add this, you want to add it just somewhere above the, or close to the top mark. And so that's a good place to start right there. before we start the titration, in that tip there's going to be some air, and we need to get the air out of the tip. So we just take some waste beaker, place it underneath the burette, open up the stopcock. Some air bubbles came out there. Once the air bubbles stop coming out, and we're good. Almost ready to go. Next thing, and this is important also, we need to make sure that we read the initial volume. This is the initial volume of the burette. Remember, we're going to measure that 2 places past the decimal. One little trick that helps is if the lines here are dark colored like these are, if you put something light in back of it, it's easier to see. Also, if these are light colored, put something dark in back. The contrast makes it easier to read. So reading this, remember 2 places past the decimal, we're reading the bottom of the meniscus. To me, this looks like 3.19 milliliters, estimating that last digit. So that's my initial volume. Now I'm ready to start the titration. Have my KHP in here, indicator, I know it's there because it's yellow, magnetic stir bar. On the stir plate, it's stirring. So now, when I start, I made sure I read my initial volume. I'm going to twist this stopcock 180 degrees each time. And at first, it looks like nothing's happening. Patience is the key to titrations. Actually, I saw a little splash of green in there, so I'm going to twist a little faster. The thing with a burette, the faster you twist the stopcock 180 degrees, the slower you're going because less comes out each time. So if I go like that, I'm going slower. I can see now that it's taking longer for the blue-green color to go away, which means I'm getting pretty close to our endpoint here. What I'm doing is I'm giving it a chance to go back to yellow each time before I do the next twist. Because what I want is I want just one twist, one quick twist to make it turn color and stay that color. Pretty close. I think maybe one more twist might do it. It's green there. It's kind of on the low end here. One more twist. Maybe another one. And there we go. That's it right there. So we're finished. Now it's really important that we record the final volume from the burette. So once more, put something light in back because these are dark marks. And to me, this looks like it's 22.90. So I'd write that in my data table. So there's going to be 2 more titrations like this of the KHP to standardize our stock solution. Fill the burette back up each time. Take the next solution, titrate it just like this. And then we're going to do the same exact thing 3 times with an unknown acetic acid solution. The difference being that we measure out 10.00 milliliters with a volumetric pipette into the flask. But same thing, add the indicator, titrate with the sodium hydroxide up here. And then the unknown we weigh out about 0.5 grams into each of the flasks, water, indicator, titrate it with the sodium hydroxide from here. And that's really all there is to it.